Welcome back to the Cisco CCNP route training from TrainSignal. Again, my name is Joe Reinhardt. I'm your instructor. We've discovered and discussed the basics of OSPF as well as design principles. Now we want to actually dig into the advanced topics, and we're actually going to do this in two lessons. This is the first of two on the advanced topics. In this particular lesson, we're going to look at OSPF authentication. We're going to look at different OSPF network types. We're going to consider OSPF area types and a little bit about default routes. First, let's start with OSPF authentication. First, we're going to get a good understanding of what OSPF authentication is, what it does not do. We're going to look at what it takes to configure OSPF authentication. And then we're going to finally verify that OSPF neighbor authentication has been enacted correctly. So first, let's understand what OSPF authentication provides or does. The first thing it does is it restricts what devices may form neighbor relationships. If no authentication is configured, then any device that sends an OSPF hello packet can actually create and establish a neighbor adjacency. This may not seem like that big of a deal, but I can tell you that in a company I worked for a number of years ago, there was a customer, it was actually a large military base, where someone actually plugged a very small, basic, consumer-grade type device that was running OSPF, and it announced that basically it was the OSPF designated router, and it brought half of the base down. It wasn't intentional, but you can see that if OSPF authentication had actually been used in that particular instance, that could have been prevented. So it restricts what devices can form neighbor relationships. It actually authenticates all messages sent between the configured peers, the configured neighbors. And it can prevent denial of service type attacks, or the type that I just described as well. Now let's be clear on what neighbor authentication does not provide or not do. It doesn't encrypt traffic. The packets themselves in OSPF may not even be encrypted, the authentication packets, but certainly the contents of the payloads are not. It also does not provide any type of data privacy whatsoever. So how does OSPF neighbor authentication actually operate? Well, there are three modes: Type 0, Type 1, and Type 2. Type 0 is essentially no authentication, and it's the default. You don't have to configure neighbor authentication. Type 1 is there is actually authentication being done, but it's being sent in clear text. And Type 2 is the MD5 hash is all that's being sent. It requires configuration of a pre-shared key on all neighbors. For instance, in our lab, we're going to be putting this in OSPF Area 0, the frame relay neighbors. So it will essentially be on Router 6, Router 7, and Router 8's serial interfaces. Authentication is actually completed on a per interface basis. So in our particular lab, it's only going to be on those interfaces, not on all the interfaces on the device, although certainly it could be. And parameters for the authentication being used can actually be set per area as well. So the first thing you have to do in configuring OSPF neighbor authentication is you have to define the pre-shared keys. If you want to use the plain text option, you use the IP OSPF authentication key, and then whatever the key is, interface subcommand. So in our case, if we were going to do it in clear text, it'd be interface 0/0 on R6, and IP OSPF authentication key, my OSPF key. That would essentially just define the key. There are no multiple lifetimes of keys like there are in EIGRP and RIP. For MD5 mode, it's IP OSPF message digest key number, MD5 and string. And again, this is also done on the interface. Once you've defined the key, you have to actually create the process on the interface. For plain text, the IP OSPF authentication interface subcommand. And for MD5, it's IP OSPF authentication message digest. Both those commands need to be on the interface or it won't operate. If you want to actually designate settings for an entire area, you can actually go into OSPF router configuration mode, and if you want to use plain text, you can do area, like for instance, if we were doing it for Area 0, we do Area 0 authentication. If we want to do it with MD5, it would be Area 0 authentication message digest. Verifying that OSPF authentication is actually functioning is a fairly simple and straightforward process. If you had neighbor relationships up and functioning before and you configured authentication, then it should drop and then come back up. If the neighbor relationship is not reestablished, then something is incorrect. But you want to be able to verify those neighbor relationships are functioning. You start with show IP OSPF interfaces, show IP OSPF neighbors. You should see all the neighbors you expect to see. If one's missing, then there's a problem. Like for instance, in our R6 environment, it should see 2 neighbors. R7 should see several neighbors since it has other areas, and then R8 should only see 1 neighbor. Debug IP OSPF adjacencies can display neighbor exchange messages to show if something's being denied. And then finally, set NTP because that can actually help in clock synchronization issues. OSPF actually has the ability to be able to designate different types of networks, each with separate behaviors. So we want to actually look at those different network types, understanding what they do. We also want to be able to figure out how to configure them, and then finally verify that they're functioning as expected. First, what are the purposes and what is necessary to understand in these different network types? Well, each network type has specific accompanying behaviors. First, will it discover neighbors by multicast hellos, the 224005, or will it require a manual configuration process, a lot like what was required in our basic lab exercises? It also specifies whether or not a designated router and backup designated router are going to be elected on a particular segment because they're not always required. And then also it can define if one or more neighbor is involved or even allowed. Network types are actually configured on a per interface basis using the IP OSPF network type command, and we'll talk about the types in a moment. Each network type creates different impacts on configuration. First, there's the broadcast network type. This type of network discovers neighbors by multicast hello. It elects a DR and BDR. It sends hello packets every 10 seconds, and multiple neighbors are permitted. Ethernet networks are the most common broadcast networks, although if configured a particular way, frame relay networks can operate in the same manner. Next, there are point-to-point network types. This still discovers neighbors by multicast hello. It does not require a designated router or backup designated router. If you do the show IP OSPF neighbors, you will see full / and then nothing, because that's a point-to-point network. There is no DR and BDR required. It sends hello packets every 10 seconds, and only one other neighbor is permitted on that segment. If you only have 2 neighbors, for example, on a VLAN, only 2 neighbors, you can use the point-to-point network. It's not the physical topology. There's certain things that are by default, but you can use this. I've used it in a number of labs as well. A third type of network is the non-broadcast network type. This is what we used in our lab. It requires manual neighbor configuration. There are designated and backup designated routers elected. Hello packets are sent every 30 seconds. Multiple neighbors are permitted. The point-to-multipoint network type on multipoint interfaces discovers neighbors by multicast hello, elects a DR and BDR, sends hello packets every 30 seconds, and multiple neighbors are permitted. The final type of network is point-to-multipoint non-broadcast. It requires manual neighbor configuration. It does elect a DR and BDR, sends hello packets every 30 seconds, and multiple neighbors are permitted. Again, these are per interface configurations and can be very helpful, particularly on frame relay networks. Configuring the different types of networks, again, it's done per interface using the IP OSPF network type command, broadcast, point-to-multipoint, point-to-point, etc. And how do you verify the network types are working? Well, again, make sure your neighbor relationships are functioning. Show IP OSPF, show IP OSPF interfaces, and show IP OSPF border routers can actually show your area border router configurations. As we mentioned previously, OSPF is a very strict protocol. It utilizes a hierarchy. It implements the use of areas. One of the things about areas is that there's more than one type. And so we actually want to look and explore about the different OSPF area types. First, we want to know what they are, what's involved with them, understand them. We want to know how to configure those areas, and then how to verify that they're functioning as expected. So the first type of area is the backbone area, or area 0. If you happen to be running a single area OSPF network, You don't have to actually call it area 0. You can call it anything you want to. There's a large range of integers that you can use. It's the transit area for all other areas. It accepts all LSA types because by nature it's the backbone or transit area. Then there's the normal or standard area. This is the default area type. You don't have to do any special configuration other than area and whatever the non-zero number is. It accepts all LSA types, inner area, intra-area, external routes, etc. Again, contains calculation for routes and SPF within that area. The next type of area, this one's actually important, is called a stub area. It's configured using the area number, stub command under the OSPF routing process. It accepts LSA types 1 through 4, but it does not accept LSA type 5s or external routes. There's a default route that's generated for external destinations. Couple restrictions about stub areas. It cannot be a backbone area. Area 0 cannot be a stub area. It cannot use virtual links, and it cannot have an ASBR located within the area. It violates the whole principle by which a stub area would be defined. A step further in a stub area is the totally stubby area. It's configured using the area number stub no summary command. It accepts only LSA types 1 and 2. That's the router LSA and the network LSA from within an area and by a designated router. It doesn't accept LSA types 3, 4, and 5, the summary routes, the routes of the ASBR and external routes. A default route is generated for all destinations outside the area. This can be very helpful and usable in branch offices that don't need awareness of everything. You want to be able to have them part of the routing process, but they don't really need to know about everything there is. It could be a simple way to configure it. So what if you need to redistribute routes in a stub area? Is there some way to do that? Well, there is. It's called the not so stubby area. Some of these names can seem very entertaining. It's sometimes called an NSSA, and it's configured using the area number NSSA command. And there can be a totally not so stubby area. You do the no summary command with that. It accepts SA types 1 and 2, router LSA, network LSA. But it allows one or more routers to act in the role of ASBR. But in the NSSA, those external routes are created in what's called an LSA type 7. Once it reaches the edge, the ABR leading out of the NSSA, then it becomes converted into a type 5. And as I said before, there's an option for a totally not so stubby area. Configuring these types of areas is fairly straightforward. For stub areas, it's configured on a per area basis using the area number stub command. In this case, in our router 8, it would be under the OSPF routing process area 8 stub, and that would be it. Now, if there are multiple routers in the area, the stub area, they all have to have this statement in there or our neighbor relationships won't form, because remember, the stub area flag has to match. It either is there or it's not. If stub area is configured on a router for an area, that has to match. Totally stubby is the same syntax, only you add the no summary in each router in the stub area, so it'll just generate the default route. For NSA and totally NSA, again, it's configured per area, doing the area number NSSA or area number NSA, say, no summary command. For instance, if we were doing it on R8, it would be router OSPF 1, area 8, NSSA, no summary, just as an example. So how do you verify the area types? Well, there are several commands that actually list the area type. For instance, show IP OSPF without anything else after it will list configured area types. Show IP protocols will actually list and actually give a count of the types of areas, normal areas, stub areas, and so forth. Show IP route OSPF should list active OSPF routes. If you see N1, N2, or stubby area default routes, it tells you that it's a stub area. And you can also do the show IP OSPF NSSA external if you want to be able to display NSSA data. So a number of diagnostic commands that can help you verify configured area types. So we're back in our lab environment and just wanted to show a little bit about the configuration of the types of areas. We're in router 8, which you recall we were going to have the area 8 that's connected to this designated as a stub area. We could do a little bit to show the situation as it's set up. Show IP protocols. It says number of areas in this router is 2, 2 normal, 0 stub, 0 NSSA. So that's one indicator. Show IP OSPF was another command we talked about. Notice here, it lists area 0, the backbone, and it also lists area 8. No authentication, number of other things in here, but that's one of the ways of looking at this. We do also show IP OSPF database. Area 0 is listed, and it also lists things for area 8. So let's configure terminal. Configure terminal. Router OSPF 1 area 8 stub. So now let's repeat the commands we were looking at before. We can go back to show IP protocols. Now look, 1 normal, 1 stub. Show IP OSPF. Lists the backbone. Now it lists area 8. It is a stub area. Generates cost 1. And that's really all there is to be able to configure a stub area. If we were actually configuring multiple routers, we'd have to go around to all of them, but it would create a problem if they didn't match. But that's just an easy way of both configuring and demonstrating whether or not stub configuration for the area is configured correctly. So now we want to consider default routing. We want to look at it how it's a little bit unique in the OSPF. We want to understand default routes. We want to configure them, and we want to be able to verify that they're working correctly. First, just understanding what default routes are. Why would you want to use a default route? It can communicate paths to other networks for host routing. We talked about host routing in the review of IP routing. It can designate the path within an enterprise to basically internet-facing routers. It can also, for small locations or locations, branch offices, and so forth that only have one connection in and out, can make routing very simple. The mathematical significance of the default route, it's the most general route possible. It's saying that the broadcast address on a LAN is essentially broadcasting to everything. The 0000 network is essentially saying match everything. So for being able to reach internet-facing routers, it makes a lot more sense to do that than rather have extensive IP routing tables. Default routing in OSPF is very easily configured. First, you have to actually have a static route or a redistributed route that points to network 0000. And this is, the standard IP route command. You can create floating static routes to have maybe more than one or a default backup route. You could do a administrative distance of 2 for the primary route and 250 for a secondary route, as pictured here. Then you need to import the route into OSPF. And the first thing you have to do is redistribute static. Take the static route and actually import it into the IP routing table. And in EIGRP, if you remember, that pretty much was the beginning and end of the story. But in order to be able to have whichever router is carrying that route to actually propagate it into the OSPF domain, you have to use the command default information originate. It's saying that that router is going to act as an ASBR and is going to originate that default route. And you can also do the default information originate always, meaning it's going to be route's going to be announced even if it's not in the IP routing table. But I'd recommend actually not using the always unless there's a compelling reason. How do you configure if the default route's working? Well, first, you do show IP route OSPF and it should show up. It should show up as a E1 or E2 route depending on how you have it configured. It could even be an N1 or N2 route depending on how it's configured. If you do show IP route 0000, it should show a lot of details. Show IP OSPF database, look for the route, the topology information for 0000. And show IP OSPF border routers. It will list ASBR information, which is what would be contained in this. And then you can actually ping or trace to a public IP address to make sure that routing is working correctly. So some terms to be aware of. Message digest, it's also referred to as OSPF authentication type 2. Requires the use of an MD5 hash of a pre-shared key to authenticate packets sent between neighbor routers. Broadcast, it's an OSPF network type in which neighbors are discovered through hello messages and a designated router and backup designated router is elected. A point-to-point network is a network type in which neighbors are discovered through hello messages, but only two neighbors are permitted, and there's no DR/BDR election. A stub area is a special area type in OSPF in which all external routes are blocked. They're not permitted. LSA type 5s are not permitted. A totally stubby area is a stub area that also then filters out any additional routes, so that only LSA types 1 and 2 are allowed, the router LSA and the network LSA, and that all others are simply summarized using a default route that's generated by the area border router. And the NSSA, or not so stubby area, it's a special area type that functions like a stub area but can actually allow for redistribution of external routes using LSA type 7s, and then those are in turn translated to LSA type 5s by the ABR. So we've covered a lot of material. We've looked at OSPF authentication, what it does, what it doesn't do, how to configure it. Network types, point-to-point, broadcast, non-broadcast, point to multi-point, and so forth. Area types, stub, totally stubby, not so stubby areas, etc. And then finally, default routes. Thank you for your time. We'll be continuing this discussion in part 2 of the lesson and look forward to talking to you later.